We design data circuits for solving problems. Let us consider a problem. There are three motors in a room. A cooler should be triggered when two or more motors are working. We should trigger the cooler for reducing the heat. The first stage of developing a data circuit is define the problem by using a truth table. So you are converting the problem to a truth table. Okay, your final picture, it will be something like this. There are three motors. You have developed a circuit. To that circuit, three input lines are coming. The line A will be 1 when motor A is working. The line will be 0 if motor A is off. Line B will be 1 if motor B is working. Line B will be 0 if motor B is not working. Line C will be high when motor C is working. Line C will be 0 when motor C is not working. Okay. Then your circuit has one output line. It is called F. This will be high when two or more input lines are high. Our task is first develop a Boolean function for this output line, then a circuit which will implement that Boolean function. Convert this problem to a truth table first. We can represent three motors as A, B and C. These are the input lines to your circuit. Since there are three variables, you will be getting 8 combinations. This is the output line, and this F will be high when two or more motors are working. So in this combination 0, 1, 1, B and C are working. So your output line should be high, and here two motors are working. Output line should be high. Here also high. Here also high. So this output line is triggering the cooler. In all other combinations, your output line will be low. So first stage is over. You have converted your problem to a truth table. Next is, from this truth table you will be constructing a Boolean function. First stage is problem to truth table. The next stage is deduce a Boolean function from this truth table. How to construct the Boolean function from this truth table? That is the next question. For that, what you have to do is consider only the combinations for which the output value is 1. Okay, in this truth table, for this combination 0, 1, 1, the output is 1. So we have to develop or define a term which will produce a logic high only for the combination 0, 1, 1. It is A prime, it is A prime BC. Okay, that is A prime BC will produce a logic high only when A is equal to 0, B is equal to 1 and C equal to 1. Then here your output line is 1. The term will be A, B prime, C. That means A, B prime, C will produce a logic high only when A equal to 1, B equal to 0 and C equal to 1. For all other combinations, A, B prime, C will produce a logic 0. Then 1, 1, 0, the term will be A, B, C prime. This term will produce a logic high only for the combination 1, 1, 0. The last one is A, B, C. And I can call this terms min terms. And I can designate them. I can designate this term as M3 because this is the min term corresponding to the combination 0, 1, 1, and 0, 1, 1 is the binary pattern for decimal number 3. So I am calling this M3 and calling this M5 and calling this M6 and calling this M7. Then I can write the Boolean function as f equal to a prime bc or a b prime c or a b c prime or abc. The output line should be high when any one of this term produces a logic high. That is, the expression will produce a logic high for the combination 0, 1, 1, 1, 0, 1, 0, 1, 1 or 1, 0, 1 or 1, 1, 0 or 1, 1, 1. I can write this in this way also, f equal to m3 plus m5 plus m6 plus m7. This way also I can write it. And there is one more way. It is if with three variables a comma b comma c sigma 3 comma 5 comma 6 comma 7. This way also I can write. Now we have constructed the Boolean function. The next stage is simplify the Boolean function because we want to reduce the size of the circuit board. For that we have to reduce the number of gates. For reducing the number of gates, we have to reduce the number of variables. There are three methods for simplification. First one using Boolean algebra. Then second method is using K-map. And third method is tabulation. There are three methods. Then we will construct the circuit of the simplified Boolean function.